So sorry. All right. So, like I've been hinting kind of all along, second semester is about doing everything backwards. And so, the rules that we had for doing derivatives, we need corresponding rules to help us do antiderivatives going backwards. All right, so give yourself, go down to like the second line of where your notes would be because you're going to need to write something above your other one. Let's just start with what we were just kind of playing around with x to the n. We learned a rule for the derivative of x to the n. The rule was, bless you, move x to the front and then decrease by 1. Okay, move n to the front and decrease by 1. So we need a rule for an antiderivative. All right, you know you're working with an antiderivative when you have capital F. All right, capital F is going the opposite direction. And so what we need to do is do everything exactly opposite, even the order in which we did it. So the first rule we learned was multiply by n and then subtract 1 from the power. Do the order and the process exactly backwards. So remember, the process was multiply by n, which was the power, and then subtract 1. Okay, what is that exactly backwards? Not subtract 1, you got to change the process. You still have your order the same. Okay, look at your order. We said multiply by n and subtract 1. Oops. Okay, that was step 1. This is step 2. All right, you have to reverse the order of the steps and the process of the steps. All right, so if we reverse the order, simply reversing the order would do this. Subtract 1, multiply by n. All that did is reverse the order. We have to reverse the process as well. So it's not subtract 1 anymore. What is it? Add 1. And it's not multiply anymore. Oops. Okay, so the process is now add. And it's not multiply anymore. The process is divide. And it's not n, which was the old power. It's the new power. And what's the new power? N plus 1 is the new power, because we just created it. All right, so it's add 1 and divide by the new power. So it's multiply, that's the exact opposite order. So this is what it looks like. We have x to the n plus 1. We add our power up first, and then we divide by the value of that new power. Whatever you learned for the rule for your derivative, the process and the procedure, the steps and the order are exactly reversed. So the first was multiply by the old. That's why the new rule is divide by the new. So I want to apply that to the question that you just did, number 36. Okay? All right, so our example is question 36 from the homework. We were given 1/4 x to the negative 3/4. To come up with the antiderivative of that, the 1/4 doesn't affect anything. It is a constant sitting out front. It doesn't change anything. So the rule now says if I'm going to find the antiderivative, we're going to add 1 to this power. So add 1 to that. So that will give me x to the 1/4. And then I want to divide by the value of what that new power is, which is also dividing by 1/4. So it's x to the 1/4 divided by 1/4. We want to clean that up a little bit. So that's 1/4, that's your coefficient, times x to the 1/4. And then Lucas, instead of dividing by 1/4, the math is multiplied by the reciprocal, so we multiply by 4, which ends up as just x to the 1/4. Plus, you always have to remember that there is a constant c as part of an antiderivative. That there could be a constant there. So go back to your rule and add plus c there. Every time you do an antiderivative, there would be a plus c. All right, so the procedure is going to work backwards for all the derivatives that we did. And we're just going to work our way through a whole bunch of them for practice. And remember, well, how did I used to do that? And now how am I going to do that now? All right. So let's put maybe a box or something around this rule. And this is the rule for polynomials. And we spent several days just working with polynomials. Well, what other kinds of functions do we need rules for? Or did we learn rules for? Trig. Okay, what else? We're going to need some rules for trig. What else? Exponentials, logs. Okay, all those different ones. All right, let's do some trig. Okay, so we learned if f of x is sine ax, we learned that f prime, okay, you tell me. What did we learn? What's the derivative of sine? Cosine. And then what did we do with the ax? And then what did we always remember have to do? What do we call that? What rule is that? The chain rule, okay? Well, there's an anti-chain rule. All right, if there was a regular chain rule, then there's an anti-chain rule. All right, so let's learn the opposite. F of x. Okay, so instead of, if the derivative of sine was cosine, what do you think the antiderivative of sine is? Negative cosine of ax. And instead, if the chain rule was multiply by a, what do you think the anti-chain rule is? Divide by a, and then plus c. All right, so right next to it, we'll do the rule for cosine. All right, we originally started learning cosine ax. So you think about, well, what was the derivative of that? F prime, the derivative of cosine was negative sine ax times the chain rule of a. Okay, so the antiderivative that would come from that would need to be opposite in all the different ways that I did. So instead of being negative sine, it will be positive sine of ax. Instead of being multiplied by the chain rule, it will be divided by the chain rule, and then it will be plus c. Yes? Okay, we will get to that. Yes. It has to do with area. All right, so let's put a box around these as the two primary trig functions. We'll come back to the other trig functions that you learned. All right, so I'm going to turn mine sideways, and I'm going to say, okay, those are trig. All right, we talked about exponentials. Okay, so f of x being an exponential. So an exponential would be like a to the u. Okay, well, we learned the derivative of this. The derivative of an exponential is a to the u itself multiplied by what two things? Not quite. Okay, multiplied by the natural log of a, and multiplied by what other thing? U prime, okay? The chain rule, which was U prime. Okay, the antiderivative of this, so capital F of x. All right, it will be a to the u. I don't have to change that, but it will be divided by both ln a and u prime plus the constant c. Okay, because the derivative was dividing by those two things, the antiderivative is simply, because the derivative was multiplying by those two things, the antiderivative is simply dividing by those two things, and remembering plus c. All right, that's the exponential. F of x equals ln of u, or a. We did a just pretty recently, so we'll do a, which could be anything. We learned that f prime of that is 1 over anything times the prime of that anything. That is what we learned. Okay, here's where ln itself doesn't have a good antiderivative. Okay, so unfortunately this one we can't come up with it. The only way this works is if I'm going to write next to it, if you start with something in your function that is 1 over a times the a prime, if that's in that format, then by memorizing you have to know that the antiderivative is back to the ln of the absolute value. I always just use absolute values to keep it positive, plus c. All right, so I'm going to do those side by side. There is no way without a calculator, without Math 9, to do the antiderivative of ln a by itself. The only way you can go is by recognizing 1 over that anything being the natural log. So that is a pure recognizing. And you look at it and you're like, it's 1 over, and your brain's got to go, 1 over, I know what 1 over is. 1 over has got to be natural log, 1 over anything. And that's just pure memorization. You memorized it the first time, I'm sure you can memorize it the second time. I was just going to do that. Okay, so other logs. Do you remember, Abigail, what we did for other logs with a different base? I'll just put base b there. What? And? Okay, almost. It has the 1 over a in it, the 1 over anything. And then it has the 1 over the natural log of b, and then it has the a prime. So it has all the same pieces as a natural log, it just has the extra 1 over natural log of b. And so you would need to recognize if it comes in that form, that would be the antiderivative into a different regular log. And so I guess, yeah, so then we would have to say, okay, if your f of x was 1 over something and it had a 1 over ln a in it, that's sort of a clue to you that the antiderivative on that is going to be a regular log base b absolute value a plus c. That does not happen very often. It is much more common to just have it be than that without that there. Okay, so this is in the category of you just have to memorize 1 over. So then here comes a real tough question. Were there any other derivatives that were 1 over besides natural log that you remember learning last semester? Because there were a couple others that we memorized. The inverse trig. All the inverse trigs are 1 over. And those are going to be straight memorizing also. Okay, so f of x, if it's 1 over x squared plus 1, that was a special case who had a special, it came from a special function. And 1 over the absolute value of x times the square root of x squared minus 1. That was a special case, and that came from a special function. And then the third one, 1 over the square root of x squared minus 1. That was a special case, and that came from a special function. So these 3 are ones that you're going to have to straight out memorize again. You memorized them the first time. Now you just have to look for those forms and remember where they came from. Let me just clean that up here. Okay, so if you see 1 over x squared plus 1, that is not a natural log. That is a special case whose antiderivative is tan inverse plus c. Okay, it is a singular special case. What's the only way it would be cotangent inverse? If the numerator was negative. Okay. All right, the one right next to it is again a special case. It's sort of a dead giveaway. If you see something with a square root and absolute values in it, it's like, it's so awful looking that you'll hopefully recognize it. That is a dead giveaway to being the inverse secant plus c. Again, if it was negative, it would be the inverse cosecant. And then finally, this last one is just a simple square root with x squared minus 1 in it. That one is the inverse sine of x plus c. Okay, and these inverse trig ones are simply, you just have to recognize them by sight. Yeah, I have it backwards. I have it right in my notes, and I just wrote it wrong for you guys. Thank you. It's 1 minus first. I flipped the page a little too quick. Okay. Once you have these, the rest of the homework is just drill and practice, drill and practice, drill and practice. So let's try. Okay, drill and practice, drill and practice, drill and practice. Here we go. If you are given f of x to be e to the negative 3x, and you're asked to find the capital antiderivative of that. All right, sometimes I go to myself, okay, it's e to the negative 3x. If I was doing a derivative, I'd have times ln e, and then I'd have times negative 3. I think, oh, that was the derivative. Okay, the antiderivative, change that to a division and put parentheses around it. Now it's an antiderivative. But what else does an antiderivative need? Well, now it's an antiderivative. Now I can clean that up, because what's ln e always? Our friend Lenny is 1. So this is e to the negative 3x over negative 3 plus c. That's a little bit cleaner way to write that, because the ln of e is always 1. Okay, so these problems should go pretty fast. It's just a matter of just practicing how they're going to go. Okay, here's another one. Okay, f of x to be cos half x. So sometimes really I think about it this way. I think, okay, the derivative was negative sine half x times half. That was the derivative. Now how can I make that an antiderivative? Well, I make it positive sine x and I divide by half, and then I have plus c, and now it's an antiderivative. So I did my rules backwards. And then maybe we want to clean that up, because dividing by a fraction is an awkward way to leave an answer. And so I'd think maybe you want to say, oh, that's 2 sine half x plus c. How do you check your work? How do you make sure that what you did was right? Take the derivative again. And I should end up, if I take the derivative of what I have, I should end up with what I started with. And that's a quick way to check your work. Okay. All right, how about f of x being equal to 2x minus secant squared through 0, 3. Find the antiderivative. All right, capital F of x. All right, it's just asking the question, where did it come from? So what is the antiderivative of 2x? X squared. Minus, okay, where did sine squared or secant squared come from? It came from tangent. That was, we memorized that back in the day. And then to make it a full antiderivative, I say plus c. So what's the 0, 3 there for? Yeah, we're going to plug it in to figure out what c is. 0 is the x value. 3 is the y value. And so 3 equals 0 squared plus tan 0 plus c. So 0 squared is 0, tan 0 is also 0, so I get 0 plus c is 3. So c is 3. This is called a particular antiderivative because you were able to not just leave it as the general c, but to find the actual value, which you were kind of doing a little bit of that in your homework over the weekend for practice. Now I've been using a lot of Newton notation. What if we use Leibniz? What if we said dy dx is equal to 1 over x minus 1 over x squared plus 6 through 0, 1. Whoops, not plus c yet, sorry, plus 6. Can't read my own writing. Okay, well this is just Leibniz. It's the same way as writing derivative. And so the antiderivative would just be plain y. Okay. The first 1 over, what's that antiderivative? That is natural log, careful, absolute value of x. Unless you're going to specify your domain later, but I just always do it this way. Now, is the next one also an absolute value? The answer is no. Okay, 1 over x squared is not an absolute value. Only 1 over x to the first power is an absolute value. So what's 1 over x squared? Well, let me check my 1 over things. I had a couple of them. Are any of these just 1 over x squared? Okay, so it's not an inverse trig either. So how do I do that? Well, what's another way to write x squared? We're almost done. Okay, negative x to the negative 2. This is just a power. This is going to follow the polynomial rule, where you raise the power up and divide by the new power. So what would the new power be if I raise it up? Negative 1. And I have to divide by divide by -1. So this would be minus x to the -1 divided by -1. That's how you do that one. And then plus the antiderivative of 6 is 6x. And we need a new plus c at the end. And then you plug in 0, and you plug in 1, and you'll be able to solve for your c value once you plug that in.